Okay, so hello and welcome back to another Unity tutorial. In this one I'm going to be teaching you how and why to use the navigation system. Obviously the why is going to be very obvious. You'll be here because you want to add navigation, so pathfinding for enemies or clicking to move units or so on. Basically a way to have almost like limited movement on a grid-based system, and obviously I'll explain how it looks in a minute and how to add a few basic features of it because it's quite an expansive topic. So I'll just cover movement and obstacles in this, so obviously you can move around objects and so on. So I want to start off by thanking the donators on Patreon, so thanks to Paul Robinson, Fulbaum and Wesley for their $5 donations this month on Patreon. If anyone else wants to help support, the link is in the description below. Anyway, so for this you don't need to have anything prepared. I mean, what I have is just a cube on a floor, so quite simple. Now, one important thing with navmeshing, there are other ways to have dynamically baked nav meshes, but we're going to have a static nav mesh. Now, static just means not moving. So, for example, this floor is static. It's never going to move. The player, though, is, or this is the thing we're moving. So, what we want to say is that how a nav mesh works is it's a grid that gets generated on static objects that don't move, and you can tweak settings to make it so some objects aren't navigable. So for example, this floor, we want the player to be able to walk anywhere on the floor. So what we'll do is we'll click on the floor, so here it is, and up here where it says static, you can check static. Now usually the main reason people check static is for lighting reasons. If the game knows that an object is never going to move, it can calculate good lighting, like high quality lighting. Here are all the different options for static, but if it's never going to move, you might as well just press static. Check the box. It actually sets them all to on. And now, if we go to navigation, now you might not have this window by default. So what we'll do is we'll go onto window. If you're on the newest version that I'm on, so the beta version, it's window and then AI navigation. Though by default, I think it's just window navigation. You can find it yourself. I can't remember what it's like on the normal Unity. But anyway, so once you click that, you get this weird looking kind of window on the inspector. And so I'll explain quickly what everything does if I know everything. I'm not exactly certain on everything on advanced, but anyway, so on basic, which is what you're going to be using all the time, this 0.4, which is here, is the step height. Now, nicely, as you tweak the parameters, it tweaks this little image. So the step height is obviously how high in terms of units can it go up. So if a certain ledge is bigger than 0.4 units, like higher up than the one below it, you won't be able to get up there. Obviously, as you see, the slope, the agent height. So, for example, with gaps, like if there's a certain thing that you can't get under because of your height, then obviously, then you can do the radius, which is just the width. So obviously there'll be tight spaces you might not be able to get through because of your width. And then the angle, the degree slope, is obviously if we've got like a ramp, it will calculate the angle of each part of the ramp to let you know how high up you can go. And by default, just leave everything like this. And yeah, this is just the default thing for everyone. Then we'll go on to jumping and dropping in an upcoming video if anyone wants more videos on this. But what we'll do is we'll just press bake. Now, as you see in here, it goes blue. Let's drop this here and go scene so we can see it nicely. So we get this like blue grid. And basically the blue grid is just a nav mesh. And all that means is it's a big area where that object can move. Anything with the nav mesh agent component can move on it, which obviously I'm going to explain in a minute. Now, it has kind of like an edge distance. Obviously, that's so that you might want to make your character run to the edge, but you might not want them to literally stand on this edge, like right on the line, because that would be a bit silly. So if you actually go to areas on here, you can give things different layers, basically. So obviously, walkable, not walkable, and jump. We'll go into those. Then on here, see, there's all the different parts. Now, we're on floor. If we went onto like event system, as you see, this is relevant to what we're currently on, so it's the object we're on, so floor, and so on. You can actually just filter, let me go back, we don't want just terrains, we want all. Now, agents, basically, humanoid is default, and this is the settings for an average humanoid. You might have different creatures in your game that have different radiuses or heights, or they're able to go up steeper slopes, so what you do is you press plus and you make a second type, so you might have something else, so humanoid, and then you might have some, really thin creature. I can't really change the name. Oh, it's right there, sorry. So the name, I don't know, goblin. And this goblin, it might be a bit thinner. So what is it? By default 0.5, so let's say like 0.35. And the height, instead of 2, could be like 0.75, for example. and then the slope height might even be a bit lower, and so on. You can tweak depending on the different objects. Now you might wonder, like, why do I even make these? Where do they go? What's the difference? So basically, as well as having the NavMesh to be able to navigate on, you also have NavMesh agents, which are things that can move on the NavMesh. So by default, you press play, nothing happens. This cube here is our player. So we're going to add a component called a NavMesh agent. And this, as you see here, has an agent type, which is an enum thing, which actually are the choices that we've made over back in the navigation. Now let's say it's humanoid by default, all right? And as you saw, we've tweaked the settings, so like humanoids can go differently to goblins, like where they can get to and stuff. So base offset, well, as you see, we've got this cylinder here, and this cylinder is basically where on the object does it calculate. So normally when you have colliders, you have rough estimates. Now on a box, you can have an exact box, but on most complicated meshes, you just have an estimate for the collider, and it's the same with this. You always have this shape. As far as I'm aware, you can't get other shapes, but you can tweak like the height and radius of it. So by default, it fitted it pretty well to our cube. It's like as perfect as it can get. Obviously, we could tweak the height of it and the radius and so on. But the height and the radius should really be the same as our actual agent type and so on. And we've got quality. Obviously, low quality will be like less costly, but it's default like that. I'll just leave it. And so on. Off-mesh link is when we've got two different nav meshes that are separated, but you can get across them by using jumping or different things which we'll get onto. And to be honest, this is fine how it is now. We've just got the speed and angular speed. Obviously, angular speed is rotation. So if we're facing this way and we need to move to here, it's how fast we can move like the camera, I guess. Like how fast we can rotate to face it. Obviously, you don't handle rotation in code. The NavMesh system does that for you. But we also need a way to handle, well, we need to tell the NavMesh agent, this NavMesh agent, we can call functions on it to actually make it move, but we need to access the NavMesh agent on it. So what we can do is on our camera, we're going to write a NavMesh controller. So let's call it player NavMesh camera. I don't know. And how this camera is going to work is, by default, we'll just have a transform invisible game object to say, go to this place. And then to end off, I will show you how to do it firing raycast by clicking on the ground and going to where you click. So what we want to do is, in this script on the camera, we need to, first of all, we'll store a, what do we need to store? Well, we need to store a reference to this script on our, on here. We need to store a reference to the script in the player NavMesh camera. The NavMesh agent. So what we can do is we can have a private NavMesh agent. Now, as you see, that's not there. So if I went NavMesh agent and just call it NavMesh agent, it's going to be like, nope, you don't have that. So one of the options is to import the NavMesh system. So using Unity engine .navigation, .ai, sorry. There we go, NavMesh agent. Okay, so we're using the NavMesh agent. Now we're going to store reference to that script, so we can control all the values on it. We can check things. Basically, we just have complete access to that player in terms of his like NavMesh components. So what we're going to say is we're going to also store a private transform, which, as you know, is just a position in the world. I mean, technically, it's more than just a position. It's got more data to that. We can do transform.position to get the actual position. We'll call this target location. And that's where we're going to we're going to pass that in, and that's where we want our guy to move to. And we're going to do it dynamically by clicking on in the world afterwards, but for now, we'll just set it. And what we want to say is on the start method, so void start, we want to say NavMesh. No, we've passed in a NavMesh agent, so that's fine. We want to say NavMesh agent. So we're referencing this script, NavMesh agent, and we go dot, and we can access all the things on it. And one of the functions, which is very helpful. Why did I say happy? One of the very helpful functions is set destination. So set destination, as you see, it takes in a vector free, sets or updates the destination, and that's basically just means it's going to move there. And it's going to move there with the speed and all the angular stuff that it has on the player specific. So basically, it's going to use all these numbers, speed, angular speed, acceleration. That's what it's going to use to get there. We just need to tell it where to go. So the place we want to go to is target location. But as you see, that's a transform, and it wants a vector free. So we just do dot position. So we've got the target location dot position. So we're just going to say, as soon as we start the game, move to that place, you know? And even in code, we can tweak the speed. If you have a player in your game and you have a speed variable, it actually makes more sense. Well, you wouldn't actually do that if using NavMesh. You would tweak this speed. You would tweak the NavMesh's speed. So if we press play, it's not going to work. Go to the camera, you see we have two things we have to pass in. The NavMesh agent, so it's going to pass in the cube. And the target location, so what I'll do is I'll create an empty game object. So here it is, it's just in the scene. It's all the way down there. So I'm going to move to here. I'm going to press Control Shift F. So now we've got the transform there. So let's just move that down to a height of 1. So we want the player to move to there, okay? So what we'll do is we'll press play. Well, actually, let's say we have to actually pass in target location. So if we go to the player, which is cube, and we pass in target location, well, I'm noticing the camera because the camera's handling it. So target location, sorry. Ooh, there we go. We're going to press play, and it should move, as you see here, with its acceleration and speed that we passed it. It should move to that location. Now we can actually increase the speed during the runtime, but no, we'll leave it. So it's got to the place, and it's basically trying to get closer and closer. The problem is it's already there, so it's just awkwardly jittering around trying to get closer. Now you can actually tell it, I think, what to do in terms of like getting there early. Stopping distance is 0, so we can actually say stopping distance of like 0.5 or something. So it will actually stop when it gets to 0.5, but with a stopping distance of 0, it will just keep going and try and get even closer. So if we click target location, it's going to go to there until it's 0.5, and it'll stop. Now, as you see, it's just sliding now. It's trying to get closer until it gets to 0.5, and then it stops, it goes further away, and it tries to get closer again. And it's just like an infinite loop. So obviously we don't really want that. I mean, I'm not here to like perfect the system. Also, it's not helpful, I don't think, that the location is off the ground. I don't think it's really that big of a deal, to be honest. Like, I put that to 0.5, so it's actually like half of the height of the player. But this 0.5 really should be, we'll just go for 1. Anyway, that works now. Tweak the values till you're happy, whatever, given different enemies, different objects, whatever, different values. Oh yeah, I knew there was something going wrong there. Ah, I'm just silly. I actually left the height. Someone probably noticed that I left the height. Wait, I put an offset. I'm just stupid. Height of 0.5. And then the radius. Okay, that's all fine now. Yeah. So the problem was most likely me having... I keep messing it up somehow. I mean, it's got to the place properly, but the height is half. I really can't get these numbers right, can I? What's going on? I'm so confused right now. Like, right now, everything is in the right place. There we go. That's moving right, isn't it? If it's not, then I'm just going to get really annoyed. No, it's fine. Okay. It's fine. It gets to its location. You could actually tell it to properly stop elsewhere. I just want to say the height of the cube is 1. If I put the offset as 0, it actually goes up. So if I put the height as 0.5, the problem is, as you can see, it only uses half of the guy. So that was right how I just had it. But anyway, now that we've got that and we can move to a place, what if we want to basically click, click, click and have it move around, okay? Well, what we need to do is we need to do a raycast and get the position where we've clicked on and send it to that position. So we already have the data we need, but now we don't really need a target location. So if we go to the code and just get rid of the target location, when we start, we don't really want to do anything. We just want to have an update listening for mouse click. So void update. We can split this into functions if we need to, but it's just a standalone video. I can just quickly show it. So we need to do a raycast. So we need to store data from the raycast. After we fired off, obviously I've done videos on raycast if you need to know. We fire off the ray and we want to get back the data of where we hit. So we can say raycast hit what I hit. Now before we do that, we actually only want to bother creating that local variable when we click. So we can just say if input.mouse get mouse button down 0. So if we left click, we'll do this code. So if we left click, then create that and equals, I don't think we have to actually set it to a new raycast hit, but we'll do that anyway. And then we can say, all right, so we've got a new raycast hit. We then need to do the raycast. So if physics.raycast, and now we need to say, all right, there's lots of different parameters. I've covered raycast quite a bit. We've got 16 different options to do, and now I'm messing up my brackets, so there we go. So if the raycast, now what do we need to pass in? We need to pass in our transform position, so transform.position. We want to go forwards, so transform.forwards. Actually, no, sorry, we don't want to do that. We want to do the actual click from the mouse. Now, one cool thing is if you actually, in this same project, I did... Oh, did I actually delete it? No, I did it here. So just like this, when I did the shooting, I would click on the screen and it would convert that screen, wherever I hit on the screen, to a world position. So as you see, we can actually, the ray can be where we clicked, so we just use the screen point to ray. So if I just use that same system here, we can say ray equals screen point to ray. So we have to say, we have to store the camera components. So private camera, we'll just call this main camera, I don't know. And in the start method, we want to say main camera is equal to get component camera. So we can't type camera. So now that we've got reference to a camera, which is ourselves, we can then say input dot main camera dot screen point to ray, and we pass in input dot mouse position. So basically, it's going to take wherever we clicked on the screen and put that into a ray, which is what it takes in here. So ray, and then it takes a max distance. So we'll just say mathf dot infinity. But we also want to pass in, so that basically just means it'll go as far as we want. There's no max range. We also want to pass in the raycast hit out. So we'll say out what I hit. And what that means is we're passing it in, but it's also going to put some data back onto it. So we're going to have an output. If we hit something, it's going to put data on this what I hit. So after we've hit something, we can say we want to set the destination. So NavMesh agent.setDestination, and we want to pass in a vector3. Now, what I hit, the data that gets back, has all these values, and one of them is point, and point is the position in the world in a vector3, which is what we want, of where we clicked. So if we click on the ground in a certain place, it's going to set that as our location. So what we can actually do now is I can go back and I can give it a second, and the camera, there we go, it's just got the NavMesh agent. So now, theoretically, when we click, it should go to these different places that I click on. So whenever I click, it's going to set that location as the place to go to. Now, obviously, yeah, you will notice this little weird thing that's going on with the jittering when it gets to the place. And that's simply because, as far as the NavMesh agent is aware, it will keep going till it gets that location. And because you set a, how far away it can be, like 0.5, the problem is, basically, you want to disable it when you get to location, or you want to just set the speed 0, or something like that. I don't know what the best practice way to do it is, but the point is you can click around and you go to all these different places, and when you click somewhere, it goes there. So the way this is good is, let's say, for example, you make an RTS game, which is like StarCraft 2 or the old Warcraft game. Basically, when you select units and click to move them, that type of system, that's what you'd use for this. You'd have a NavMesh of the map, and you'd be able to like drag select things and then click, and the things would move there. You'd also have to make your own anti-flocking system where they avoid each other. I don't think that's built in to do this really. So like obviously if you had a group of 5 guys that you want to go to here, they would all go around here. They wouldn't all go to that exact point. But you get the system and it works. So obviously I hope you can do this too. You can do some pretty cool things with this. I hope you like the video. Obviously, feel free to leave suggestions below. That's what I want. I want lots of suggestions of things to do. I'm going to end up using the NavMesh system in my FPS tutorial series at some point, with the enemies moving to the player and then attacking in a certain range and so on. I'll implement some basic AI for that. But yeah, so I hope you liked the video. If you haven't already, like, subscribe, join the Discord server. It would mean a lot to me. But apart from that, thanks for watching, and goodbye.